Hey guys, so here's part 3 of the 7.1 notes. Now we're going to talk about the translations when we have exponential functions. So we talked about A, that is a transformation. It can tell us if there's a reflection or not, and if there's the vertical stretch or shrink. But remember H and K. H moves our graph horizontally while K moves it vertically. Now let's kind of talk about this. If we have X minus H, remember that means that we're going to move to the right. And X plus H means we move to the left. So remember, this is when we talked about you do the opposite of what you see. Okay. Now K is exactly as we see it. So we have a positive K. That means we're going to move up. And we have a negative K. That means you're going to move your graph down. So when we graph these and we have translations, meaning you have an H and K, or H or K, we're going to graph the parent function first, then use our H and / or K to move the graph. Okay, so this allows us to use the same 5 points to plot, -2 to +2, and then just move everything. So this is when our asymptote can also be affected. And so what's going to affect our asymptote is the K value. So if you have a K value, that will move the asymptote. Okay, make sure you have this down on your notes. Now we're going to go ahead and graph where we do have translations. Okay, we're going to graph y equals 4 times 2 to the x minus 1 power minus 3, and then state the domain and range. So as I said, what we're going to do is graph the parent function. Now the parent function is going to be the a times the b to the x. So I'm going to go ahead and write that actually here as well. So we're going to graph parent function first, and that will be y equals a times b to the x. And then you will use the translations, or I can say use H and K to translate the graph. There we go. Okay. So you might want to write that down as well. So pause the video if you need to write that stuff down. Okay, so here, what our parent function is going to be y equals 4 times 2 to the x. So the idea is that you get rid of the H and the K, okay? So that's where you get your parent function. So I get to use the same 5 numbers that we did in the first 2. And once again, you can just put this into your calculator, okay? So here, what we get, is I get 1, and then 2, 4. So remember with our A value, notice that it is a number greater than 1, so this is going to be a vertical stretch. Okay, there's no reflection since A is positive, and then our y-intercept is 0, 4. So remember, it's 0, the A value. Okay, then 1, 8, and then 2, 16. Okay, now I plot this with the asymptote. So remember, just with y equals a times b, your asymptote is at y equals 0. So I do -2, +1, then -1, 2, then 4, then 8, 5, 6, 7, 8. The other one we will not see. Okay. Now what I'm going to do is I'm going to use a different color to represent my actual function that I have to graph. So since I have that, now it says should move blank units right. Remember, that is going to be your H value. Okay. So notice our H is going to be that 1. So I'm going to move 1 unit right. So each point, I'm going to move it to the right. Now, then we should move blank units down. That's going to be our K value. That's going to be 3. So I move 3 units down. So we have our h, and here's our k. So each point I move right 1, down 3. So I go over 1, down 1, 2, 3. Now, before actually I should graph these points, the thing you should do is actually graph your asymptote. And remember, it's the k value that will affect the asymptote. So we need to take our asymptote and actually move it down 3. So 1, 2, 3. Now I draw that, and now I write the new equation of y equals -3. Okay? There we go. So anytime you have a k value, use it to move your asymptote. And don't forget, make sure you write the equation. And it's always y equals since we have a horizontal line. Okay, now I'm going to do the points. Move over 1, down 1, 2, 3. 3. Over 1, down 1, 2, 3. There we go. So when you're probably deciding, well, how am I going to know which graph is what? Well, you can use different colors. That's fine. You can also use like maybe a solid and then one solid and then the other one is a dotted line, so you know which one's which, okay? Or just draw an arrow like this is the parent function, this is the original function, right? Okay, now that we did that, now we need to figure out domain and range. Well, domain should be easy, always negative infinity to positive infinity, no matter what. Range, we're going to find range of the blue function because that's what we are graphing, right? So remember, it depends on if the graph is above or below the asymptote and the asymptote itself. Well, since the graph is above the asymptote, we're going to positive infinity. The y values are increasing. So we go from the asymptote there, and remember we use parentheses, and our asymptote here is actually at -3, and then we go to infinity. Okay. Okay, let's try one more problem just like that. I would like you guys to actually go ahead and pause the video and try this one on your own. Okay, let's see what you got. So we are going to go ahead and graph the parent function. That's going to be y equals -3 to the x, and that's it, okay? So our a value actually in this case is -1, okay? So that means since it's negative, we are going to have a reflection. And so since we're going to have a reflection, it is going to be below the asymptote. And really, there's no vertical stretch or shrink because when we take the absolute value of -1, it's positive, and that's neither greater than or in between 0 and 1, okay? So you can kind of put that if you need to. There is a reflection, and then no vertical stretch or shrink. So just some things. Okay, let's do our here. So we should get the numbers of like -1/9, -1/3, then we just get -1, -3, and -9. I graph my original asymptote. 2, this is going to be here, -1/3, boom, and then 1, 2, 3, 4, boom. Okay, now I connect. Now I decide where to move. Here's my h, here's my k. Remember, h is the opposite of what you see, so I should move 1 unit left, and then our k is exactly as we see it, so I should move 2 units up. Remember, the k value is the one that affects your asymptote, so I actually go up 2, draw that new line, and it's at y equals 2. I move each point left 1 and up 2. Going to go a little bit off the graph. Okay, and remember your graph shouldn't touch or cross that asymptote. Now we do our domain, and then our range. Whoops, I did this incorrectly, I just realized. Because you know what? I graphed it above the asymptote. So let me redo this here. That was my mistake. Okay, we still have this. I'm going to regraph it because I just noticed I graphed my y values positive instead of negative. So I did not reflect, which I should have. Okay, so let me regraph the parent function. Then I'll move everything left 1 up 2. So I go down, here we go. So I'm at negative 1/9 at negative 2. Boom, here we go. So some of you might have been like, this doesn't look right. Yeah, it was not right. And then 4, 5. This is 9. Yes. Okay, now that it's graphed correctly, now I can move everything. I still move my asymptote up 2. There we go. So now I go to the left one, up 1. There we go, 2. Over 1, up 1, 2. Over 1, up 1, 2. There we go. That looks about right. Okay. So now my range, because my graph is below the asymptote, that means the y values are decreasing. So we go from negative infinity, and then our highest value is the asymptote. So that's going to be at 2. Okay, make sure you guys work on the homework assignment. If you guys have any questions, make sure you contact me. I'll see you guys later.